equations, we need to know the different properties to allow us to solve stuff. It's a little quirky. What we're going to do is called expanding and condensing logarithms. And they all work with certain properties and stuff. And it takes a little while to get used to. So we start with these. Properties of logarithms stem from what's called product when you multiply. So we have logs, base b of u and b. You just split it up to the addition. When things are multiplied together, you can split it up to the addition between the two logs. And what I'm going to do is kind of go through each of these and write an example at the same time. So if you have log base 3 of 2x, that means you can write it as this. Log base 3 of 2 plus the log base base 3 of x. That's what that means that you can do.
Should we write down all these properties?
Yes, because you're going to use, there's only 3 of them, but then we start to mix them all together, and it can get pretty messy real quick. Quotient, remember quotient means division. So if you're dividing with logs, means you're subtracting the two. One of the main reasons why we have these properties that go back and forth like this is so that way, sometimes within logarithms, within each part of the problem, you might be able to simplify something as you're going along. So that's why we still use these. So if we have division, we show what that would look like. Yeah, I'll get there. When I don't put a base next to a log, bless you, what's the base? 10. Good. So that just means it's log and that's where this comes from. Let's see.
Is that x and exponent? Log of 3 x?
No, it's log base 3 of x.
Right, so it's not that.
No. Nope. And the last one is the power property. So anytime you have something raised to a power, you put the power out in front of the log. Power goes out front. So if you have log, nice save. If I say log base 4 of x to the 5th, that just means it's 5 times the log of base 4 of x. And why that's helpful, or why this actually works with the power ones, if you think about it, if you have, let's say it was log base 4 of
Wait, is that a power?
no.
The x?
No. And that's why it takes a little getting used to how you're writing this stuff out. I try to make the bases really close to the g, and then that way you know that's the base. Then the next number that comes up is just of the log. Your bases will never, the base of a logarithm will never have an exponent on it. You're never going to see, log base 3 squared of x. You're never going to see that.
No, I meant
Okay, you're never gonna have a variable in this portion of the logarithm, ever. So don't worry about that. It would always be that. It's not 3 to the x, okay? This base value, when it's part of a log, will never have an exponent, okay?
No, I meant, was the x, like an exponent of the log?
No, the x is, you're taking the log of this value. That's what that's going. So it lets you do stuff like this. We can rewrite. So if I have log base 3 of 3 times 9, if I rewrite that out, I can rewrite it and simplify it. We'll do these kind of one at a time, I think. So if I do this, I get log base 3 of 3 plus log base 3 of 9.
So what is an exponent?
It's not an exponent.
But it's not like times 9, it's like exponent 9 up at the top.
No, it's not. There's no exponent here. There's no exponent. This is all in the same line.
The 3 is a subscript.
Okay. This is the subscript. That's a regular script. It's log base 3 of 9. So does this help when I put that line there?
Yeah.
There's no exponent. Okay. Don't worry about that. What's log base 3 of 3?
3?
1. Now, can I rewrite a 9 as a base 3? What do you get? Now, doesn't that break into the idea of something to an exponent? What can I do with that exponent? I can put it out in front of it. Yes. And that's why this works. Because 2 times the log of base 3 of 3 is what? 2. So that logarithm simplified out to be 3. Also, if you go way back, isn't that 27? Isn't that the log base 3 of 3 cubed? Which equals 3. That's why the properties work, because you can do stuff like that. Okay, that's why they work. That's why we're able to move things around back and forth and be able to eventually get values of x and solve for stuff going through it. Yes, sir?
If it was so easy just to get the 27, why didn't you just get the 27?
I'm just showing why the properties work. Because not always will be that quick. Okay, it might not be that quick. Same deal in the next one. The next one here, what I would have to do is move that 5 out front first. If I do that, I get 5 times the log base 2 of 4, which is 2 squared. The log base 2 of 2 squared is what? 2. And you get that. Okay. That's why we can use these properties, just how these things work themselves through to be able to simplify out. Okay. What I did there is I was doing this quick little, that trick from last week. How the inverse properties work. I'm just doing that little trick. Okay. There's a lot of stuff that hides within logs, not just termites and stuff. Oh, it's so good to feel better. Oh, I feel so much better. So if we take log base 3 of 1/3, that means that we can rewrite it via division. If I do that, I get log base 3 of 1 minus log base 3 of 3. What's the log of 1? What's anything that's log of 1? 0. And what's log base 3 of 3? What's 0 minus 1? What's 1/3 written as a base 3? What's 1/3 written as base 3? 3 to the negative 1. That's why the properties work. Because you can go back and forth like that.
Why is it 0?
What's the log base of anything of 1?
Anything of 1 is 0?
Right. Because 3 to the 0 is 1. Bless you. When we first talk about the properties of logarithms, log base b of b is always 1, and log base b of 1 is always 0. Because when you work back and forth of them for going to exponential form, that just means it's b to the first power equals b, and b to the 0 power equals 1. That's why those properties work. Same deal with the next one. Next one, you can write it out in 2 steps. You have the 3 out in front of log base 5 of 1 minus the log base 5 of 5. Which again becomes 0 minus 1. And you get that real quick. So as you can see, there, as we get to our test eventually, next week, like Wednesday probably, there will be calculator and non-calculator. Because yes, could I just throw that in the calculator and get an answer? Did I ever show you guys where the log base button is yet? Let me show you that might as well show you that real quick so that we can check your answers with some of these things. So let's say I wanted to type in the log base 5 of 1/5 to the 3rd just to check my answers and stuff. If you hit alpha window, option number 5. Alpha window option number 5 gives you log base. And then it automatically is blinking on the cursor for what your base to be. So I put a 5, and I move it in, and then I'm going to do my fraction bar. 1/5. And then I have to raise that to the 3rd.
Okay, I thought that was 0. I'm thinking first is 0. Right there. Log
It is.
minus 1.
It's 0 minus 1.
Oh.
What's that?
Why does that say that?
Why is the calculator doing that? Oh, you know why? Because I forgot to put the 3 in the wrong. Oh, I should have the 3. It should have another. The 3 should have been on the inside. Sorry. Oops.
So you put like an exponent or something?
Yeah. I should have had an extra parentheses in here. I forgot to get this one that does that. Did it work then?
Yeah, you have to put that one.
Yeah, if you have an exponent, you have to have, see how I have it captured on the inside there? I forgot that the calculator does it's thinking more literally. What I did here is that it simplified the log base 5 of 1/5. It got that answer, and then it raised it to the 3rd power. That's why I originally had -1. But here, what is wrong with this thing today? Oops. But by putting the exponent in the parentheses, it simplifies it out the correct way, okay? So these you just have to be careful where you put your exponent. Delicious. cinnamon flavored coffee today. Cinnamon, no, it's vanilla. Whatever. So then it gets to even be more fun. Expand log base 2 of 7x cubed over y. And you're going to see this terminology a lot. Assume that all variables are positive. Reason we say that is because we can't take logarithms of negatives. So we're going to expand log base 2 of 7x cubed over y. Now, what you have to be careful of here is how you start to write this out. Notice in your numerator you have a monomial. You have multiple parts. You have 7 times x cubed. All of that's being divided by y. Okay? So what happens is you start mixing together properties. And what you get then is this. We have the log base 2 of 7 plus the log base 2 of x cubed. But can I go ahead and move that 3 to the front of it? Because it's a power. Is that okay? We all right with that? I just did that in one step instead. But here's the thing. This is the whole numerator. And then you divide it by the denominator. You have to make sure you put parentheses in these things. Okay. When you're doing division, you have to be careful about what's being divided. Is it just one part of the numerator? Is it one piece? Is it just one singular fraction? Or is it a bunch of stuff in the numerator and then division? Or does the denominator have more parts? So you have to make sure that you just throw some grouping symbols in there for the division stuff. And it's kind of it's easier to see where you're going then. Okay? It's not really as tricky as this might get. Yes, ma'am?
How is adding those and then, and then subtracting the last one, how is that like equal to dividing?
The properties. What happens is whenever you have multiplication, you can split it apart into 2 logs via addition. Whenever you have division, you split it apart into 2 logs via subtraction. When you have exponents, the exponent just drops into 1. Now you've done it. Okay. And the reason we look at these properties is because when we go to solve equations, we have to know how to split things apart and put them back together. That's why we show these properties. These are too easy. Do that one. All right, let's see. We get log 6, 3 log x. You okay, Kathleen? You seem kind of, are you getting the ickies?
Maybe.
Don't get the ickies. It's not good for you. Trust me. All right, let's go backwards. Let's condense. Condensing logarithms, you're working backwards. Hence the word condense. You're making it all into one giant log. So log of 6 plus 2 log 2 minus log of 3. Now, unfortunately, sometimes the book is notorious for not putting parentheses in. But you can see probably where this is headed. Does everybody agree that there's multiplication, exponent, and division here? Okay. So we start with our regular log, our log base 10 of 6. Then what? What's it being multiplied by? 2 squared. And then what? So then from there you could probably simplify it. What do you get? 8. Yeah, log base 10 of 8. So by condensing some things, you're going to be able to simplify them as you go through. Sir,
I'll get where you got all the twos.
the twos? This is a power property. Since this is a, oops, since this number is out in front of the log, anytime you have log base b of u to the x, that's x log. So this exponent drops up front. So since it's up front, it's the exponent here when you rewrite it.
What's the equation? What was the original thing we had?
This whole thing. This was the original expanded form, and then we just condensed it into a smaller log. We chopped it up so it would fit in the fireplace. I'm just trying. Trim to fit. It's like when you get mini blinds, and you gotta have them cut to the right width. We just cut them to the right width, so you can install them, and your wife is happy. You'll learn these things. Do those two.
Which one is it?